In this set of notes, we're going to be solving radical equations. So one of the skills that we're going to need to know is how to square a radical. And if I square a radical, you can think of that several ways. This would be the square root of 5 times the square root of 5, square root of 25, which is 5. So the square root of 5 squared is 5. You could maybe imagine it a little bit better even using exponents. So the square root of 5 is 5 to the 1/2 power squared. And then we have a power to a power. This is going to give me 5 to the 1, which is 5. So a couple different ways you can look at it. The square root of 5 squared is 5. So we're not going to take all this time because this is going to be something we're going to repeat. So anytime I have a square root squared, it's going to undo their inverse operations, and whatever the radicand is will come out, and I will get x plus 2 there. On this one here, the square root of 2x minus 4 squared, inverses work, and I get my radicand out. So thinking, oh, well, cube root to the 3rd power, same situation. I'm going to have a 5a, the radicand that comes out. So this happens as long as the index and the exponent are the same. All right, so to solve radical equations, we're going to get a radical alone on one side of the equal sign. We'll then either square or cube both sides of the equation, depending on what we have. Then if there's still a radical, we'll get it alone and square or cube again, and then we'll solve the remaining equation and check the solutions. So it's going to be important for this group that we check our solutions because we will come up with some extras and we'll have to throw them out as extraneous. And we'll talk about that again on a later page. All right, so example 1, we have a radical that's isolated on one side. So now we're ready to square, because I have a square root. I want to raise this to the 2nd power in order to bring the radicand out of the radical. So 5x minus 1. And then 3 to the 2nd power is 9. So now we're ready to solve it. And so we're going to subtract 1 from both sides. That will give us 5x. We're going to add 1 to both sides. That will give me a 10. 9 plus 1 is 10. Then divide both sides by 5, and I get that x is 2. So I want to check that. So I'm going to take my 2, plug it back into the original equation. So I have 5 times 2 is 10, minus 1 is equal to 3. So that's a square root of 9 is equal to 3. And at that point, we can see that that does check, and that x equals 2 is our answer. For B, this time we have a cube root, and this time it's not that cube root is not alone, so I need to isolate it. So I'm going to first have to move the 3 over. So I'm going to add 3 to the other side. So 5 cube root of x minus 2. Add my 3 to negative 18, and that gives me negative 15. Then I still need to remove the 5, so I'm going to divide both sides by 5, and that's going to give me the cube root of x minus 2 is equal to negative 3. All right, so now I've isolated my radical on one side of the equal sign, so alone over here. And now, because I have a cube root, what am I going to do to both sides? I'm going to cube it. So I'll show this in a separate step, kind of make that real obvious. So I'm going to raise both sides to the 3rd power. And then this will bring out that radicand, so x minus 2 is equal to negative 3 to the 3rd, which is negative 27. So then I'm going to add 2 to both sides, and that gives me x is equal to negative 25. And I want to check that. I want to plug that back in up here, and that gives me negative 25 minus 2 is negative 27. So the cube root of negative 27 is negative 3. Negative 3 times 5 is negative 15. And negative 15 minus 3 is negative 18. And that does check. on that. So my answer is going to be x is equal to negative 25. So now you stop the videos right now before we get anything more complicated, so you won't think it's that hard. So go ahead and try examples C and D before moving on.